I guess we go on now to the last event, last feature of the conference. I managed to close my presentation. I think I did. I don't know how. And I see, yeah, well, that which is the workshop, and Tito is gonna be the host for that.
Yes, yes, I have a slide to share and questions and topics to think about. Um, shall we start?
Yes,
Uh,
please
yes,
go ahead.
Nicholas, just how much time do we have for this?
I would say we have as much time as we think we need. As long as there are people interested in discussing the topic, we continue.
Very good.
Uh,
Good to know. Excellent. Okay.
it has
Uh,
been about an hour the other two times, which
yes, yes.
should be
Okay.
right.
Very good. Mm, I think I'm sharing my own screen here. Oh, here it is. Okay. Let me put it in presentation mode. Okay. All right. Uh, hello, everybody. Good to know that you are there. I'll be kind of hosting the workshop, and it's based on the topics that we have covered during the day 3 here, lunar mining and manufacture. And the subtitle will be "What Must We Mine and Make to Survive?" So basically, taking inspired on the topics covered here on the abstract that we have seen of presentation that we have seen. And here are some of the questions. Yeah, they're kind of a little bit long, but basically, that's what they are. Questions about energy and power, construction and infrastructure, water and volatiles, life support and agriculture, materials and manufacturing, energy and power. Again, oh, sorry. No, sorry, human factors and ethics. I need to fix this. It's human factors and ethics. And uh, it is simple to fix. Oh no, here. And this goes as okay. Now we have it. Okay, human factors and ethics, and what's and logistics and scalability. So, uh, well, these are some of the questions. I leave them for you to read and maybe be a sort of a seed for thoughts we have heard. I'm just going to kind of wrap all the things that we have seen. We have heard about thorium. We have heard about the PGMs, platinum. Oh, sorry, PMG, platinum metal group, and helium-3, and also we have seen well about water and IC regolith again, and the all the needs that we will require in the moon, and that's one of the things that was being said on all the presentations is the uh, we have to get there. The first thing is we have to mine, and we have to build infrastructure, foundations. Okay, so the beginning will be all of them will be inflatables and uh, things that temporary, and then later we will need the pads, the launch pad or landing pad, and so on. The same with other things like water, life support, materials and manufacturing, human factors and ethics. Also, we can talk uh, cover some of them, and logistics and scalability. But I'll leave this open for you if you have thoughts or things. Uh, um, please do so.
See that?
So all of the systems that were discussed today, all of the mining systems, you're probably going to try to minimize the number of humans and maximize the number of robots or automated systems. But does seem to me that you're assuming that all of the life support and agriculture issues have been worked out, that there will be habitations for humans, and that they will live comfortably and be able to work efficiently. That's asking a big amount for a field that is still pretty raw. But I think would be one of the major contributions to the Earth's life support system.
Yeah.
To recycle our wastes into our resources would help Earth enormously. And I think that that's one of the contributions that the space program will make to Earth.
I agree. I think that's a key thing. It's not then about mining and manufacture. It's about recycling, which is part of everything, sort of.
Yeah.
Jim?
I figure that the first people we send to the moon are going to carry their food, their shelter, everything they need to live. But what we want those people to do is ultimately use the local resources to be able to expand so that the next group that comes doesn't have to bring their shelter, they don't have to bring their food. And so we have to break down what exactly we need to produce the ability to live on the moon.
Yes. Stuart is on queue here, so let's follow the order.
I'm thinking there should be another category here, which is related to medicine, like pharmaceuticals and things that you need for a doctor would have.
Yeah, good point. We need to add.
Is the presenter on mute, or he hasn't spoken for a while? So.
No.
Oh, Victor. Yes. Thank you.
Go ahead. Go ahead, please. I think let's allow in order. Next one will be Frida.
Well, I think that things like pharmaceuticals, cell phones, electronic equipment, I think there's always going to be a certain amount of material that is a lot more convenient to simply ship up from Earth, just as there are going to be things that you can manufacture on the moon that will be more efficient. But pharmaceuticals are one of the things that takes an enormous amount of input to make a very, very tiny output that is critically important. I don't see these systems as being completely independent of Earth for a very, very long time. And I think there'll always be a certain amount of material that will be transported from Earth. We certainly do have to think about what pharmaceuticals are going to be needed and which ones can be effectively produced remotely, like on the moon. But I think that for probably hundreds or thousands of years, we're going to be continuing to exchange materials.
There isn't any country on Earth that's self-sufficient, so I don't see why we'd expect the moon to be.
So that's a very good point. So maybe we should adjust this slide to specify a level of self-sufficiency, like 90% or 95% or something like that.
Well, I think there's going to be a need for kind of a strategic resource plan so that we can kind of plan to bring those kinds of things and be able to produce some on site so that at least you have some capacity. Because if you end up sending someone to Mars and they need to produce medicine and it's not going to be helpful for them to wait 6 months for it to show up or 2 years for it to show up, right? So having that capacity is actually very important if we want to have the actual capacity to be self-sustainable. And building a roadmap to making that possible when it comes to compounds, for medical compounds as well as industrial compounds, probably a really good idea. So that if we can't produce them on site for the first 50 years of colonization, we bring that stockpile with us and can drop it off. So that if they need that resource, they can apply it to.
Good.
Very good. Okay. Wolf? Yeah.
Yes.
Ah.
Speaking about fertilizers, the things you actually need are basically mostly the micronutrients for plants. That is nitrogen, phosphorus, and potassium. If you have that in let's say good amounts, that is fairly good. Every other thing you can find in very small amounts that biological life needs. And if you have, let's say, organics, you can almost use chemical synthesis to produce most of the medicines. I mean, they are produced from organic materials anyhow. So nitrogen, phosphorus, and potassium is essential.
Very good.
I think
Thank
that's
you.
why it's important in my little bottles to show that these chemicals need to be recycled, and my current system, for example, does not adequately recycle them, and that is going to be an important process. That we can't have essential elements tied up in waste products that just are denied then from recycling. That the recycling process is going to be critical.
Yes.
I'd like to ask a very different question. I'd like to ask about how important are patents in motivating the current scientists that we've heard from today. I don't know how long patents last, and I don't know whether the patents, if you patent, for example, a conveyor belt that is intended for the moon, but it's not going to be used for another 100 years, will that patent still have any value?
No.
No. Could be argued whether the patent is valid on the moon at all, I think.
I think the value lies in it creating a roadmap that others can follow later if it's not being followed within the time of the patent.
Yeah, I don't see that
Support it.
there's any value in patenting something at this moment that the patent won't survive anyway. But I think that there's a lot. It seems to me there's a lot more altruistic work being done that isn't geared at making sure I get mine out of it. It's I'd love to see this thing operating no matter who does it. I want to be the one to do it, but I think all of us here would love to be involved in it. But I think we're all trying to work toward making it happen for the greater good.
Stuart?
So, excuse me. I think we need to have a plastics industry on the moon. So I don't see plastics in here. So probably in maybe construction and infrastructure.
There's a great deal of work about converting algae to plastics.
Yeah. So it'd be probably bioplastics thing.
Yeah.
Yeah, flax,
So
soy.
the ABO, the algae biomass organization has a lot on this.
Question.
Very good. Christine?
Question. Given the limited carbon on the moon, is plastics the best use of the carbon, or should that be more like food? And shouldn't metal be the predominant choice of material for hardware and equipment and structures?
I've been thinking we should probably look at the Victorians stuff because they use much simpler materials. Not for everything, but see if there's something that's not as effective as what we make nowadays, but much simpler to build in terms of complex alloys and plastics and such.
Maybe I see a raised hand from Christine.
Yes, I just wanted to follow up a little bit on someone asked about patenting, right? So, personally, I'm not a big fan of patents at all. But the reality is, if you want to do this as a startup or a company, then investors are going to look for patents. So it seems like it's going to be a part of this either way, I guess, depending on the funding sort of side of it. Just thought I would throw that in there.
I just want to add that I just recently read, I was following Lunar Mining LLC, Lunar Mining 3. No, sorry, Helium Mining LLC. They have closed, they have finished like 5 patents recently. So they're trying to work very hard on being the first on extracting and industrializing or commercializing helium 3. And 2 purposes. One is for the moon itself as a fuel for future and the others will be um, 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 uh, and the other is for quantum computers, for freezing quantum computers, refrigerating quantum computers on the Earth. So it will be a double use of it. Okay, please go ahead. I think there's other people commenting. Anyone else?
I think it was a good idea to define the needs in perspective to the maturity of the settlement, or because that's obviously something that it will be a gliding scale. At the beginning, it may be very little that we need to manufacture. Well, the Apollo program, there was nothing manufactured on the moon, but if we're going to stay for more than a couple of days or weeks, then we will need to manufacture at least food to start with. And then the longer we stay and the more we do, the more should be manufactured on site.
James?
One area that is advancing rapidly is battery technology. So, in addition to being able
for the sake of long-term colonization, I think that every wave that kind of arrives should be kind of preparing for the next wave.
But what I'm trying to say is one area that we need to investigate is energy storage. Basically, we use direct energy typically through solar panels. There's the potential of nuclear, but having a portable energy supply is most likely through some sort of battery system, or potentially for some sort of energy storage system through a chemical means. That's an area that I think it is somewhat has not received a lot of attention in moon activities.
Thank you, James. Doc?
I just want to point out that recycling can go a long ways to reducing shipping cost. Water is a classic example there.
Very good.
Yes, also maybe Dana sort of mentioning that if you ship containers or bags, you can make that out of material that you can therefore use on the moon. So being strategic, like, imagine a container that's made out of copper could be a simple way to get a lot of copper on the moon, which is pretty difficult to get on the moon.
I agree. It's going to be one of the things that we may need to get there for lots of things: piping, wires, electric motors, and so on. Stuart, you're next.
A couple more things. So glass would be very important. Also textiles. Something a bunch of guys don't usually think about.
Yeah.
Is there a form of textiles that doesn't require carbon?
You can make geotextiles out of basalt fibers. on the moon's surface. There have been some papers out exploring that concept.
Do they feel good to wear?
They wouldn't be textiles in the clothing sense, but they could be textiles in more construction or industrial senses. Like they could be used as filler for concrete and stuff like that.
Thank you.
Okay, following the order here, we have Bob. Do you want to add something?
Yes, I mean, when we're discussing the balance between recycling and finding resources on the moon, we have to take, let's say, quantitative assessments. Carbon is necessary in all biological systems. Everything living contains about 40% carbon, ourselves and crops and whatever. And these carbon, even if it's recirculated aggressively, we still need fairly large amounts of carbon. And the amount of carbon, for instance, in textiles made from plants. I mean, some plants are excellent for making textiles, not only cotton, but for instance, bamboo makes excellent clothes, and bamboo grows really, really fast. But it's really necessary to have substantial amounts of carbon anyhow.
So that might be a point for mining. We need to mine carbon somehow. Sorry, I barged in there.
Yeah.
Let's follow the order here. James? James, would you like to add something? Or
there's a substantial amount of carbons in the L-cross results. If we're harvesting lunar polar ice, permanently shattered regions, if we're harvesting it at quantities necessary for ascent and descent propellant, then the side stream of carbon is pretty substantial, especially if you're using it for recycled purposes like in food.
sounds very good. We see several hands raised. Any one of you would like to go? Frida, maybe?
In my imagination, I think of going back to some very, very early colonial type activities in terms of clothes. I think about things like knitting and crocheting and weaving. There are small looms, for example. I think there's going to be a need for artistic creation among the people who live on the moon. And what used to be done in the old days, especially with knitting and crocheting, which is very easy to undo. So you take a garment that has had some degree of wear, you return it to essentially a linear thread again. You cut out those portions that are actually damaged, and then you create something new, and you create different color patterns, and you create different kinds of fashions. And I think that is how a lot of the clothes are going to be recycled for a very, very long period of time, by going back to actual thread construction, or taking a garment and transferring it back into just a linear piece that you can create something new with. And I think that there's going to have to be artists and writers, and there's the human need to create while you're not doing work.
Yeah,
I agree. And I would like to add to that is, I think it's a huge trend of doing things in the retro way and on the moon, like kind of machines for mining would be kind of the old style machines. Clothes, we can do weaving and knitting and recycling from even clothes from vegetables or clothes from plastic and plastic from vegetables and so on. So there will be several options for opportunities for recycling that we have to take advantage of. I see hands from James.
Okay. I just want to make a point that $1.2 million per kilogram to the moon, I believe that incorporates the cost of development of an item to deliver to the moon. So if it's not where you would be thinking in terms of like a raw material like carbon or such, that cost would be much, much lower. So that's something to consider, that the cost of actually getting to the moon is a whole lot less than what was quoted.
Yeah, I agree. Yes. Thank you, James. Frank?
Yes. Some point earlier, Stuart made mention of glass on the moon. I just realized that this year's NIAC grants, the first round, has greenlit a project for blowing huge constructions on the moon, like basically big spherical habs. It's very retro. I really like it. Another thing that I just realized is that if we were to explore the stack of glass making on the moon, apparently there's a huge untapped water reserve on the moon in the micro glass beads that are being kicked up by the solar winds and all that. So if we were to harvest said glass, we would get water as part of the process also.
Very good. Thank you. Stuart?
Yes, air should be in the material in the manufacturing, because there's going to be a continuous need to manufacture air. There are always going to be losses, and we need to think about it as something that we manufacture continuously. Also, light bulbs, right? We're going to be dependent on lights, and there are going to be a lot of them, and they don't last forever. So, it seems like that would be a good thing to start. That'd be a good thing to start manufacturing first.
Or LEDs. I mean, you kind of use the same technology for photovoltaics.
Yeah. I don't mean like tungsten filaments, but yeah, whatever light rating thing we use.
Very good. Ben?
Yeah, one of the other things we should be looking into is how to build common stuff that we have on Earth using lunar materials. Like it was mentioned that we would need copper for wiring and motors and stuff, but we could use aluminum for that. We would just have to redesign everything to use aluminum. So maybe instead of thinking, what do we need to import to recreate terrestrial equipment, how can we redesign it to use lunar materials instead?
I agree with that. And there's something that was mentioned yesterday, I guess, is about all the works in Pisces in Hawaii, not just the analog, which is great, but the uses of basalt. And I think some ideas that I found in David Disler's book about mining on the moon. It's about sintering. We could be sintering with less energy than perhaps smelting to some point, create tape that we use, elbows, pipes, pots, plates, and even doorknobs or drawers, drawer knobs or other things that we might need.
Right. And there's been research on how to sinter using lasers, using microwaves.
Yeah.
So we do have a base knowledge on how to sinter regolith at this point.
Yeah. Great. Excellent. Ulf?
I think we should let ourselves be a bit informed by all the guys who are working with green chemistry. Those guys synthesizes all kinds of stuff and medicines and foodstuffs and whatever. And they also exchange the elements from, let's say, traditional chemistry to more or less green chemistry, not only for being, let's say, eco-friendly, but to choose different starting ingredients for chemical synthesis.
Very good. Thank
Well,
you.
I
Thank you
mean,
to everybody.
that's something like Nicholas and I have talked about how, there are alloys for steel that are common on Earth, but of course it all uses carbon, and there hasn't been a real reason to look into, well, can you make other types of steel that maybe replaces carbon with an element that's easier or more common on the moon?
Right.
There hasn't been a need to because we have so much carbon here, it doesn't matter. But chemists could go into that direction and start replacing common Earth elements with common lunar elements to see what can be made.
Maybe we will need a bunch of moon chemists.
Yeah, metallurgists. Yep.
Very good.
But not only metals,
Yeah.
but every kind of stuff that is produced by chemical synthesis. I mean, lots of materials are produced by chemistry. I mean, all kind of packaging materials, all kind of rubber and similar things, food stuff, medicines, whatever.
Right. I mean, if we're looking at lunar settlement where we're actually making things, we're gonna have to look at every single thing and be like, well, this is how we make it on Earth. How would we make it on Luna with those available materials? I mean, almost every single thing needs to be looked at again.
Yes. Yes, indeed.
Okay. Do we have anyone else? I'm just adding to the slide that, Stuart, please go ahead.
You're muted.
I'll make one more. There's a little side discussion going on in the chat about semiconductors. But some of the semiconductors might actually be easy to make because they're fairly, as long as you stick with large geometries. And the fact that there's a vacuum readily available means that, a lot of the processes are fairly straightforward on the moon versus in Earth. So it might be an interesting thing to look at to start semiconductor manufacturing.
Yep, I agree. We use a lot of semiconductors, and it would be much better to manufacture them.
Okay. Ben?
Yeah, two things. One with the semiconductors. Somebody brought up a while ago, I think at a different LDC, basically saying, like, chips don't take up a lot of space and they're pretty lightweight. So is it worth trying to create a manufacturing base for chips when we can send up a 20-year supply in a single shipment and then not have to worry about it? So one of the things we need to maybe prioritize is, what do we need to be able to manufacture soon versus what can we stockpile for a significant time and eventually ramp up to that manufacturing?
Yeah, that's a very good point. Also, the part of the equation also is the time to maturity of the technologies. When you start developing it, how long is it going to take to get there? So, yeah, those kinds of logistic questions are very important.
Right, and and we're all very used to having the latest technology. I'm sorry, what was that? No. I was just saying we're all very used to having the latest technology, but we are talking about a frontier, right? I mean, as opposed to like a mature lunar settlement that's been there a very long time. But new settlements are going to be frontier settlements, and frontier settlements typically have been lower tech, less comfort. So maybe, for the first X years, we're manufacturing simple computers using vacuum tubes because they're easily manufactured. And then eventually, as the settlement matures, it can ramp up to higher and higher technologies.
Very good. Erstein. Right.
Yes. So I thought I'd just throw in there, there was some talk about metals or steel or something earlier. And one of the things I find really interesting is that there is in some areas there's a this was mentioned earlier also, that there's a crossover between some terrestrial applications and some lunar applications, right? And one of them is aluminium production, or aluminum from anorthosites, right? So aluminum typically is extracted from bauxite, which is a very, that's a pretty horrible environmentally sensitive thing with red mud and all that stuff. But there's promising technologies on how you can actually pull that out of anorthosite, and anorthosite on Earth or on the moon potentially. So I think aluminium is a very, very interesting candidate for something that should be thoroughly investigated. And I do think both Europeans and American scientists, and also others, of course, are looking at this through, for example, molten salt or molten oxide electrolysis processes. So, which is really, really, really cool. And then your slag material, which we actually also investigated in these plant experiments, is a glassy substance which is full of, for example, calcium and these kinds of things. So not just doing this waste, or not just doing this processing as a single vertical line, but also going horizontally, using waste from one process into feeding into another one sideways. So yeah.
Okay, thank you. James.
I just want to clarify that in the case of semiconductors, you're not simply thinking in terms of computer chips, which are very, very complex with hundreds of thousands of components. We commonly assume that we're going to be using solar cells on the moon to generate electric power. And in the case of agriculture, we're thinking in terms of light-emitting diodes. So that's two areas that are relatively simple for manufacturing. Additionally, purified silicon could be an export from the moon, since we use a lot of electronics here on Earth, and the purification of silicon is a very energy intensive process.
Very good. I just wanted to add before Ulf, it's the magnitude of the escalation of population that we're going to have on the moon, and how does that justify the industrialization or the manufacturing needs that we may have. So I was thinking, okay, Artemis 3 will be 4 guys or four astronauts walking on the moon, or 1 month, or staying there, which is a lot in terms of food and some things that we might need, they may want to do. But the next one will be when 2-3 months later, or 1 year later. That's a big difference, because things need to last for some time and be operational when the next batch of astronauts come. And then later they will have not just 4, but maybe 12 or 20 people, until we reach populations bigger than that, like 200 people working and living on the moon. And that may also follow the evolution of the manufacturing technology that we may need. And so perhaps in those stages we will see changes, or adapting what we have and make it a little bit more industrial, or the needs that we may have. Ulf.
There is a saying that necessity is the mother of invention. And even if the moon will be a pioneer society for quite a long time, still we need to see resources in a new light. For instance, lots of minerals, even on the moon, I suppose, contain calcium. And calcium could be made into very robust materials. Imagine, for instance, the shell of mussels. They are quite hard. And those, how they are made could be replicated in a bit more advanced, but still not bulky processing materials. So we can have hard things, hard tools and walls and made of other elements than we use on Earth.
Very good. Stuart, please.
Yeah, I just wanted to make a comment about the pioneer society concept. I think we need to be careful about thinking that way because, like, when I think about a pioneer society, I think, about very kind of primitive stuff and like historical pioneer societies. But we have to remember that on the moon, we're going to have access to AIs, and they're going to be way better than what we have right now. We have the internet, we have all that stuff. So it kind of modifies the pioneer concept. I'm not exactly sure how much it does and in what ways, but it seems like it's going to be quite a bit different, right?
It really should. We should be using Earth technology and not be dependent on inventing everything on the moon.
Any other? Yes.
I'll add one more thing about the pioneer society if there's so
Yes, please.
another thing is that in pioneer societies they would accept like a 50% survival rate on their children, and that was part of the deal, like when you went out to the Old West. But that's not going to be like, people aren't going to accept that going to the moon, so we have to think about a much higher survival rate. So that means really good medicine and all those kinds of things.
That's one way that biological processes could come in handy, because a lot of medicines are bio-derived in the medical industry, but you could also pack some medicinal plants if you have a large enough portfolio that might come in.
I think one of the advantages is going to be that you're not going to be, hopefully, meeting another civilization that has certain diseases endemic within that population that spread to yours, or that you are spreading new diseases to another population. There was a movie years and years and years ago about people colonizing the moon and finding a civilization on the moon. And this civilization had certain personality quirks that they wanted to please people. And so if you shot at them, they fell down as if they were dead because they wanted to please you. But what really killed off the native moon population was the fact that one of the people who was very ethical came with a cold, and his viruses killed off the lunar population. It was a movie that was made years and years and years ago. I don't know if anybody can possibly recover it, but it was food for thought.
You're making a very good point, Frida. I think, like, if we are to make any sort of like permanent settlement, either on the moon or like most likely in microgravity too, I mean, these are environments that are like very easy for germs to proliferate in. And I think we have to design every surface and every system so that it can be like thoroughly cleaned somewhat regularly.
Well, I think the feeling now is that we really need to encourage good, I hate to use the word germs. I think the most recent issue of Science, for example, had the fact that human skin is not sterile, that there's huge numbers of microbes that are beneficial. And part of their being beneficial is that they will outcompete a lot of pathogens.
Oh, you could make like a probiotic environment in the lunar habitation, essentially, so as to push out like the bad germs.
But mutations will occur, errors occur, things that were harmless may become pathogenic. I wish I could write science fiction because, I mean, the real stuff is really much more complicated.
The cool thing about anything that you write is that it follows the laws of plausibility. Anything in real life just happens. It doesn't need an explanation. And you're here trying to figure it out.
Thank you. Ulf, please go ahead.
I think, speaking, continuing on what Frida said, I think microbiology will be an essential knowledge also on the moon, not only for medical purposes, even if that's important. I mean, when you consider the habitats in the Arctic, when there arrives a new bunch of people, everybody will get a cold because they have been the codes have been sort of reduced when there's a very small population, and then a new bunch of people arrive, and everybody gets a cold. And you need bacteria and microfungi and all that stuff to get lots of processes that recycle organic materials in a good way. And we are depending on lots of good bacteria also inside ourselves. And we, of course, will bring those bacteria to the moon. And they will have to function also there. And you can see, you can take samples of soil or water on different places on Earth, and they have different compositions of bacteria and microorganisms anyhow. And we are more or less dependent on them also on the moon.
I would like to add before the hands raise hands that we might be requiring some bacteria for industrial purposes as we do for leaching, for copper or copper eating or iron eating or scrap eating bacteria, and also plastic eating material maybe or some of them. So we may need to have cultures of this type of bacteria for uses, and hopefully they last and they adapt to the conditions of the moon. Frank.
Yes, I wonder if history will repeat the pattern of seeing like quarantine camps for newcomers, as we've seen for the Americas and such. Because the way I see it, given that the moon is like a high radiation environment, it could be a very mutagenic situation. And paradoxically, we could see like an incredible variety in terms of microorganisms. And like it would make sense on any like large scale human settlement of the moon to have new arrivals acclimate their microbiomes to what's already present before like releasing them in the larger population. Because if you were to have like people coming directly over from Earth with like a high viral load, you could literally murder like millions of people that way, and that's not something we want to see happening.
Well, that reminds me. I went to visit New Zealand, and it was a long trip, and they were so cautious with anything. First, they kind of spread something inside the plane, and of course, they didn't want a single fruit whatsoever. Of course, it happens in other countries as well, but I mean, it would be too a threat to the agriculture in the country because of an isolated environment. So I think that might be happening on the moon as well. Stuart.
Yeah, I was thinking an interesting exercise to cross-check this list. I mean, not for now, but just to make a list of all the things that you use during a day, like a toothbrush, for instance, and then see if that's covered by this list of what we're planning to mine and manufacture, what we must make to survive. And that would be a good way to do, like you do that in a matrix form and see, oh, do we have this covered? Do we have this covered? Or if we don't have it covered, do we really need it? Or is there an alternative? Something like that. So that would be a nice, it would be a nice completeness thing to see if we've got the bases covered.
One more thing I was thinking before Frida talks is the mold. I know we have mold is a big threat on houses. I don't know, wood and water all together. I don't know if some of these things or some type of mold will grow on the lunar environment. So or something else. I don't know. We talked in the first day about smells and other things. So I think those are kind of related in a way. Frida.
Well, I think things are fairly simple as long as you assume that every place we're going to colonize doesn't have pre-existing life on it. And I don't know whether anybody can help me with this, but I believe that there was some concern that you could have a life system that did not use ATP, as apparently every organism on Earth does, but which uses cyanide, and that therefore their life form would be incompatible with our life form. Is this just science fiction, or is there some basis for this? Or what do we do if we find some place that is colonized by something that we think is like a cactus, but they have their own intelligence and they have their own intellectual development of poetry and so forth? What do we do then?
Learn to speak cactus? Like,
is it ethically, if we find out that their cactus is capable of writing poetry and music, we don't know what our farm animals might theoretically be capable. I don't know. I'm sorry, we're getting into the fringe edges, but it is possible. I am told. I'm not an expert on the energy transfer systems, but I'm told that it is possible to essentially have energy systems other than ATP in biological systems, and that cyanide would be one of them. And cyanide is, of course, extremely poisonous to our energy system because it's energetically more efficient, I'm told. I'm speaking from pure ignorance.
I have heard that cyanide could be a potential element of life in other systems, like just in an exobiology class I had one time. Another question is also like handed amino acids, because I think we mostly use left-handed amino acids, but it's possible to find a biosphere that's flipped. And in that case, it would probably poison us like prions or something would.
Very good.
Either that or you find antimatter life forms. No touchies.
That would be a very energetic first contact, yeah.
Yeah. You guys familiar with Dragon's Egg, the book by Robert Forward?
Mm-hmm.
With the little critters living on the neutron star. A really complicated contact, but they figured it out before us because they live a lot faster than we do, apparently. It was pretty hard sci-fi. What are these?
It's a good one.
Oh, Frida, what's that?
Wow. Oh, okay. You got dragon or something.
It's too small. I can't.
Just a little. It's an earth dragon, but
yeah.
I might be wrong. Did you make these?
That's cool.
No, I have a whole philosophy about dragons, dragons to me are people who are exceedingly frightening, but if you get up the nerve to approach them, they can teach you a great deal.
I gotta show you
John
something, Frida.
Cole, okay, so John Cole, who recently died, but he did a lot of the biological work on carbon. And I had spent about 12 years working on closed ecological systems, not realizing that I had leaks and I had a serious flaw. And it took some effort on my part to get him to teach me what I was doing wrong. And it was an extraordinarily beneficial process, but it was initially painful. So to me, dragons are people who have information that we need. Anyway, as I say, I've got my own sort of mini philosophy on the importance of dragons.
If you're okay with origami, I could show you how to make these.
Wow. Very good.
Pretty detailed. They even got a tongue.
Well, I think within Asian religions, dragons are actually beneficial, but very frightening.
They're associated with rivers and very long processes. So any project that you can't see the end of in like a single day or like a week or like a month is like dragon energy. And yeah, I mean, the Chinese word for long is like the same as for dragon. So sometimes if you get like scammer emails, they'll talk to you from a Dragon Island beach or something. Yeah, that's the way I see it anyhow. And plus, like in mythology, they're very long-lived. So I would imagine like if somebody has like dragon energy, they would make plans on like a very long time scale. And they also sleep a lot and have a lot of money. I don't know where that fits in. But I like your interpretation too. I made a very solid contact actually that's tied up in Nyack, and we bonded over origami. So that's a very cool file. Very cool. Something I wanted to touch on. I don't know if you guys would have any immediate ideas, but Andrew's been talking about like potential like names for settlements or potentially like regions. I think it would be a cool thing to explore because we could pitch it to other people and make the idea more infectious.
Frank, I sort of try to align my thinking to what I think is probable and preferable, but try some combination of the both. And it seems to me as though my belief is that establishing a permanent base near a peak of eternal light and relatively close to where there's water ice of almost any concentration, doesn't have to be 1 part per 18 like Cabeus crater, that hybrid location would be a good location to start. I think a lot of people would agree with that. That's almost sort of the default thinking. So as I take a look at the peaks of eternal light, I think peak of eternal light B, which is on the connecting ridge between Shackleton crater and Day Gerlach crater. It's a relatively flat. I don't know. Somebody here probably knows the percent of the year that is on average lit at peak of eternal light B. I presume it's more than 80%. But that's where I imagine going first.
That's a very good idea, actually. Like, I like the sound of it.
Yeah.
Besides, like the South Pole is like very hard to orient yourself at, from what I gather, with the long shadows and all. So, like, it would be one of the locations that would stand out. And, geez, I wouldn't want to get lost there with limited oxygen.
Well, then don't. I mean, plan to not make that happen. I mean, they didn't run out of oxygen during the Apollo program.
The long shadows, if you carry your own lighting with you, I think you can deal with that on your immediate surroundings. You just shine light to where you're going. I mean, on Earth, nighttime is nothing but shadows, but we navigate in the night, no problem.
Have you had a chance to see the lunar base concept by Lockheed Martin?
Is that an inflatable that's up on a...
It was
lander?
a whole bunch of structures that were in interrelation with one another.
Yes, yes. Did they have a video where it's sort of a driving video?
Yes, that's the one.
Yeah. It was, there were some good things. You know, of course, Lockheed Martin is not going to take into account the Starship fleet and that capability. So I think it was limited in its reality. But there was, you know, there was vertical solar drapes, a few. I wish there would be like, you know, like 150 tons of solar drapes on a peak of Ternolite would be about 5.1 megawatts, you know, which is industrial scale power from the very beginning. So they, you know, they just don't have that vision because they imagine having to do a lot of small landers to try, you know, build up the scientific base. And I just don't think that's realistic given the Starship fleet capability.
Absolutely. Oh, any thought about the carbon upper stage? I know you're a huge Starship fan, and my take has always been that like sending the whole thing to the surface, unless you're planning to like break it down to build with it, is maybe a little bit overkill in terms of delta V.
So my space development network, we have this concept of the Star Hab, which is a starship that's landed vertically, and then you drop tethers out of the door. Telerobots, they anchor the tethers in the ground, and then you winch it over in a very controlled manner, maybe landing on a inflatable you know, pillow sort of thing. And then as crew arrives separately, they enter in through an airlock. They vent the methane in LOX tanks, and then they cut through the LOX tanks and then start installing two welded points, you know, 3 floors all the way throughout. So a single landing, you could get more internal volume than 2.5 times an ISS in a single landing. So to me, it's like, hey, let's just use the starships. And if you want to detach the engines and ship them back to Earth and reuse them, you could do that. But that structure as a habitat is just a pretty easy, straightforward concept.
And then return the valuable parts of the engines. Every 10 ship for something.
Get turbines in there. That's pretty useful. One thing I thought about that specific concept, if you were to land it on the side on a payload, why not mount some sort of like airbag directly onto the hull of the ship for that maneuver to be performed instead of covering the ground? You could pad the other side.
That's an excellent idea. I hadn't thought about that. Sort of obvious as I think about it.
Yeah, I tend to think of things backwards.
Yeah.
Surface radiation, is that a problem?
What radiation?
Surface radiation.
Yeah. So
this is not my field, but apparently when you get radiation hitting metal, it can cause other radiation within the ship.
Secondary showers, that is true. I believe the solution is pretty simple. I mean, what we did is we had tarps that create vertical walls, sort of retaining walls on either side of the starship after it's been tilted over. And then you have you know, teleoperated vehicles that scoop up the surface loose regolith and simply toss it on top, and then they just keep doing that. So if you take a look at the millisieverts per day on the lunar surface, of course you reduce, you know, from free space, reduce it 50% because you have the bulk of the body of the moon that reduces it. You would have 3.6 years before you reach a sort of notional 1,000 millisievert career limit, like for a 47-year-old male. Okay, but you got solar particle events like solar flares and coronal mass ejections that could kill you. I mean, we almost lost crew during the Apollo program because there was a serious solar flare, but it was between the Apollo missions. So my calculations, you need to get about 11 centimeters of regolith on top of the Star Hab to be able to protect against the solar particle events. And then if you get up to about that much, you could extend the amount of time from the GCR millisieverts. You could extend crew stay to about 6.3 years before reaching that 1,000 millisievert limit. And so all the crew has to do is to maintain the tail robots, and those things are operating 24/7, putting more and more regolith on. So honestly, they could land the tail robots before crew arrive, put the 11 centimeters on. When the crew arrive, over the years, the tail robots just keep building up more and more regolith, and you buy yourself more and more time so that the crew would never have to return home from a radiation standpoint. Over.
Very good.
Yeah, evacuating the moon makes about as much sense as evacuating the Earth. I mean, once you get past a certain population.
Yeah. Mhm.
Victor, I apologize. I joined late. What is the general
Yes.
topic that we're discussing?
Hello, Doc. Well, this one is lunar mining and manufacture. Is what we have covered on the third day. Basically, mining, different types of mining, manufacturing processes for different materials or different minerals and metals that we're going to find on the moon, and yeah, basically that. And by the way, we covered our presentation was based on the Shackleton de Gerlach ridge, one specific crater, Worthy, which is in the middle of the ridge, but not for the lighting. The light that is an important thing, but just because it was kind of an iconic crater that we put a conveyor, sandwich conveyor belt for extracting the material. And if we succeed on that, we can succeed in any other crater in the ridge.
Victor, I'd like to ask this group a question. My understanding is micrometeorites impact the lunar regolith at several kilometers per second. And my understanding is when it hits, it creates a little crucible and it strips off the oxygen from the rock and regolith and creates these little globules of a mixture of the metals from the metal oxides in the dirt. And so that's now unoxidized metal, which seems to me would be sort of low-hanging fruit, sort of low energetic source of unoxidized metals. Does anybody here know whether we can beneficiate that, whether we can separate the globules that are like melted into the surrounding regolith, and if we can somehow concentrate that, maybe using concentrated sunlight to melt it, remove the dross? Is that source the logical first source of metals on the moon? Because energetically, it's already unoxidized. Anybody?
Well, I think riding it and having it go through a vortex separation would be a good start. But we got Olstein from Solstice, who's pretty experienced with this.
So yeah, I think it. So you're probably talking about the agglutinants, right?
Yeah.
Yeah. So the thing is that we don't really have an equivalent type of material texturally naturally occurring on Earth, right? It's very, very specific to the moon. These like big weird shapes of sort of glass and some lithic particles in there, some minerals. There's nanophase iron in there, things like that. So I would assume it's possible to beneficiate and make concentrates with this. We just aren't really sure how to do it yet. But yeah, if it's the best source of iron, I don't know, maybe. But I mean, with technologies such as molten oxide electrolysis, for example, you just dump it all into a crucible and melt it and sort of separate it with anodes, right? But the efficiency would probably you would be able to get a better efficiency if you have a beneficiation or pre-beneficiation step. But again, I wouldn't know exactly how to do that yet.
Are we able to
something in our timeline for sure?
Go ahead, please. Go ahead, Doc.
Are we able to take the dust particles and use a beneficiation process to increase the percentage of the grains that we're working with of having these metals and not metal oxides. So might get it up to 60% of unoxidized metal, and then simply melt that, and then being able to have a separation process. So we don't. My concern. I know molten regolith electrolysis is very popular. Everybody's talking about it. And yet, if you take a look at the amount of energy to separate those metal oxygen bonds, that's a pretty significant amount. And I sort of
It's a lot. Yeah.
I consider energy to be sort of the rate limiting step. Now, mind you, if you have like our concept of solar dray, which was 5.1 megabytes, megabytes, 5.1 megawatts on a peak of eternal light, after you've taken out all of the inefficiencies, self-shading and wiring support structures and everything. When you're dealing with the industrial levels of power that we're talking about, solar power, with a single landing of a starship, maybe we're energy rich. Maybe we don't have to worry so much about energy efficiency of processes. So maybe we could just do molten regolith electrolysis and not worry about how inefficient it is. But my feeling is producing more is always better than producing less. So having a beneficiation process and getting to the unoxidized metals, to me, sounds like something we would want to do if we can do it.
I think we can do it. And again, it's something that's on our sort of future timeline. You can produce artificial agglutinates. How close they are is sort of an open question. The environment on the moon is quite different, as you all know. But I would say, I mean, there are like, when you beneficiate, what you want to look for is what kinds of sort of parameters of these particles are different, right? How can you sort of categorize them and sort them, right? And which one of these fit into these categories of, for example, electrostatically sort of chargeable, magnetically, like, can you affect them magnetically? Is there a difference in density, right? These kinds of things is how you beneficiate, and you can string several of these one after the other to sort of create these and/or gates, right? If you look at it sort of like Boolean or whatever it's called. So one of the things that I think, like, now I'm in the speculation zone here, right? One of the things that seems to me to be different about these agglutinates is that they probably have a very, very high surface area compared to like a lithic particle, I think. So maybe there is something in there that has to do with how we can charge it. Maybe it is electrostatically more susceptible, something like that, and the nanophase iron probably has some sort of magnetic signature or something which is different as well from other material. So I would just try to look into those and see if it's possible to make a concentrate which is more or less 100% agglutinates. So, and again, there are agglutinate simulants, but they are, as far as we have seen, not good enough yet. But yeah, very, very interesting question. I haven't actually thought about this before. If you can if you can actually make an agglutinate concentrate, that's a very, very interesting idea.
Would like to make a common a small comment on that. I was learning recently from a course I'm taking from Caltech about Mars, and they have these blueberries. You may have heard about that. And the blueberries are apparently hematite, nodules of abundant in hematite. That some water that came from the groundwater many millions of years ago, and it was evaporated or so. But they're abundant, and it's a presence or evidence that there's some oxides there. Just to associate with what you were saying. I know the other is by uh, uh, meteorites and all other origin, but at least have some sort of association. Any other comments or?
Have you guys discussed helium-3 mining?
Um, yeah, we discussed about the 5 patents that they have got. The helium-3 mining company has got these patents. Is Chris Albino, one of my alumni of my Introduction to Moon Mining course. Now he has company and is trying to get there and bring some helium-3.
I actually a little bit frustrated by the use of the term mining, because if you go to Google Images and you type in mining, you're going to see really heavy equipment. You're going to see dealing with solid rock, most of the time. And I just don't think that's representative of what we're going to be doing on the moon. I choose to use the word harvesting, because harvesting just sounds like it's more benign, which is, I think, what it's going to be. I mean, the gardening process of meteorites over time has done a lot of our work in turning rock into powder, and I think we're probably going to be dealing mostly with powder, and which is, people get a little bent out of shape about use of the word mining, because they think, oh, it's impossible because you got to have Caterpillar equipment. I mean, I've heard people talking about this, and when you're doing things like heat separation of volatiles, is that mining? Not like people normally think.
That would be refining at that point.
Yeah.
We will need refining technologies, but the heavy digging technologies, definitely depending on what material you're going to be digging into, will be scalable. But I think that if we have a capacity to build those machines on the moon, then size won't be a problem. The biggest machine in the world right now is a mining machine, and it took 5 years to design and build it. So I think in the long term, we will probably have heavy mining machines like that, but it will take some time to design them and then to be able to construct it. Because a lot of the mining machines are actually constructed on site at the mines based on what the needs of the mine are. So that's going to have to be determined once we see what the material is like, the volume is like, and then also the amount of equipment we can get to it.
But I guess the question is, do we actually have to move the stuff at all? We just heat it up and collect the gases?
Yeah, I mean, in my scenario for harvesting ice in permanent shadowed regions, is you beam the power to the vehicle that's doing the harvesting, that's scooping it up, the icy regolith, and then you steam it out within the vehicle itself, and then you just poop out the dry regolith, and then only after your tanks of volatiles have filled up do you then transport those volatiles back. So to me, transporting icy regolith over kilometers is like, why not separate it? If you can transmit the energy, why not separate and in situ, and then just bring back what you want?
Yeah, I was thinking helium-3. I mean, you need to essentially you need to evaporate the gases, but why move the soil for doing that? You just drive on. There's plenty of topsoil.
Yeah, that would be the case.
It might be an idea to stockpile regolith at certain points so that if you want to build a colony in the future, then you have excess stockpiled and ready for that purpose. So even if you're not necessarily bringing it all back to the base, it could be collected at a certain point for a future node to be built, so that at least the resources aren't being wasted. It could be used for something else.
I agree. Just to finish that idea, excuse me. One of the things that you would like to do is concrete of some sort, lunarcrete, or as we have seen with polymers and others, and put them there, and also use or reuse the regolith, maybe the drier regolith, for laying out roads and baking them with microwaves or something. Please don't.
I also have another issue with our usage of the term mining, because unfortunately, it oftentimes, and no offense to any of you here who are actual miners, which I respect. I mean, without you guys, we wouldn't have civilization, right? But the problem is very often when people talk about mining, they reflexively immediately start thinking about terrestrial mining and what's involved with terrestrial mining. And in terrestrial mining, you got highly developed, extremely large markets that are demanding commodities in the forms of metals or whatever. Okay, and then the mining companies that they think about customers. They do assays. They're competing worldwide, and they've got to prove that they've got an ore body that's economic. And so, and there's laws, that have been built up over centuries that regulate this. And so, if you put a terrestrial miner, if you just say, okay, think about mining on the moon, they think, well, I know mining. This is my specialty. This is my business. And so they will start thinking about, okay, this very long process of you've got to we're dealing with large amounts because on Earth they deal with large amounts. You're dealing with having to raise money because you have to raise money in totally private terrestrial mining situations. You've got to use big equipment. You've got to go underground. I mean, I've heard professional miners talking about mining underground on the moon because that's what miners on Earth do. I mean, they do strip mining, but a lot of it is underground mining. And so they're constantly bringing the terrestrial concepts without saying, wait a minute, who are the customers? And thinking not, 50 years from now, but thinking, who are the initial customers and what do they demand? And what's the minimum that you need to do to be able to meet that demand? And it may not be doing a 5-10 year prospecting phase. It may be just they need a scent propellant, and they do we need to be convincing venture capitalists to fund these operations like all terrestrial miners do, practically all, or will this be a sort of small scale meeting customer, sovereign clients, just to do a scent and descent propellant, and that's the way of looking at it, which forces you to stop thinking like a terrestrial miner and just think about what are the needs. Does any of that make sense?
I'd like to speak on this. That a key element, though, is the question of getting investors in to produce, say, propellant on the moon, because it hasn't been done before. You are going to be looking at venture capitalists, so you have to explain to them this is how we would do it and what we expect to happen, and set certain milestones so they. With each milestone leading to potentially a larger investment. But it's not something that a group of people are going to get together and say, okay, let's go to the moon. We've got the money, and then we'll just put our money into mining the water there for propellant.
James, the people with the deepest pockets are governments. The U.S. government has far more money than Elon Musk. Okay. So, I mean, even an annual budget exceeds his net worth that he's collected over his life. So won't sovereign clients be our first customers? And are sovereign clients really venture capitalists? Do they think the same way as VCs?
I think there'll be a
You gotta
combination.
figure that the answer is no, because you have to consider that they aren't there to serve the customers. They're there to serve themselves. So unless it's in their interest to go to the moon and mine the propellant, they won't have an interest. They will go and set up a scientific station, and that's their element of prestige. But anything beyond trying to develop the moon is probably something they have no interest in doing, and they haven't in effect for 50 years.
They haven't had the Starship fleet before, so I think times are changing.
Yeah, and Starship was created by a private individual. That's my point.
Do you want to answer?
Yeah, there was some aspects of the lunar mining that is like counterintuitive versus like how we do it on Earth. One of the approaches that I've been exploring with Daniel Tompkins for, I mean, it's applied to Mars in this case, but basically leveraging the dust that is kicked up by seasons on Mars through like a vortex separation, access some aluminum that could be used to like metallize plastics and use it for like reflectivity in optics applications. But it could also be done for the moon because, as it turns out, the electrostatic phenomena that we observe on the surface does kick up some dust. And there's been a lot of talk of like developing all sorts of tools to get the dust off of the suits for the astronauts. But I think we could also try to explore this to like pick up like said dust and like scoop it into like a vortex, separate it, leverage it to make possibly like aluminum-based propellants. There's also some ways that we could just use like electrostatics and like solar winds and very weird type of dynamics to explore all sorts of ways to do mining technically without having to like break excavation buckets by scooping what's deep under the ground.
Okay. Andrew, you wanted to add?
Yeah, there's also, we could create a lot of the mining equipment on the surface. We could theoretically create crucibles that could be used for refining purposes using regolith and some other in situ materials. So I think that there's a lot of things that we can scalably construct there that we won't have to build. And because of that, you could have corporations competing to then sell their blueprints to the Artemis Accords, so that essentially they can be part of the construction process. But the machine that they're building could be something that can be reproducible, because if you have something that's patented and, from the moon, they have to pay someone on Earth to build it, that's not really going to work so well, especially when you start getting further out. So creating a blueprint and having corporations sell that blueprint to the Artemis Accords so that we can fill in a strategic plan and then have a kind of a list of all the technologies we can print, and companies can compete for that right to kind of sell their product as the blueprint. Then we won't have a lot of the issues with patenting and stuff like that. That's going to be a problem if you're trying to send something out and then they got to deal with patent law going back and forth, when you could theoretically create a blueprint that would be universal across 55 different countries, and you could have different companies competing to sell that blueprint to the model, right? So I think there's a lot of different solutions that we can apply here that are just novel, that we've never had access to before. And looking at the broader picture enables us to see them. And that's kind of where I kind of look at it.
Sorry, I was mute. I was just, I have a kind of a funny note talking about expired patents, and we can use the can opener that is expired after 100 years or so, and we can still use it on the moon or some other things like that. But of course, the new ones that will have a different approach and be treated in a different way. Anyone else?
So I think that is getting quiet. So maybe we should call that today. I think the discussions have been very good and varied, and I hope we can put some of that part as part of the proceedings, or whatever you call it, book of abstracts as well.
Yeah, I can be happy to share the slide with you, Nicholas, and then add whatever comes out perhaps from the recorded session or so.
Yes, I will take some time to. Well, I have recorded all the sessions, so I will chop them up into pieces and share with everybody on the YouTube channel of Moon Society. So, thank you, everybody. I think it has been a great conference. I have been learning a lot of new things. So, just call it a day. And
Wait, before we all go,
yes.
where do you guys see yourselves in a year, in 5 years?
A good one.
Yeah, because things are moving really fast. I mean, just the HLS development, I don't think we'll see it next year, but in a 5-year horizon, that's definitely something that's on the table.
Yeah.
Yeah,
Personally, I will continue to get acquainted with the topography and the features of the South Pole. I think the better we know the names, and especially things like the light and the where it's going to be the peak of eternal light, that would be a great thing to remember and also promote. And of course, more ideas of challenging ideas for technologies, techniques, or even the old ones that we want to adapt for the moon, and make them succeed. I mean, maybe better. I would like to see my own ideas with animations and things that are more realistic. I need to learn more from Blender and Unity, but
Is the question is where will we as individuals be in 5 years, or where will, progress to development of the moon be in 5 years?
I assume both.
I think that's the same.
Yeah.
Well, no, I don't plan on being on the moon in 5 years, but I
Not with
think
that
we will.
attitude.
I think we will. Well, I think we will have landed cargo on the moon, and probably people as well.
If we're lucky, we'll have some telerobotic rovers we can play with.
That'd be a very
Oh.
interesting thing.
Yeah.
I do think that by 5 years there is okay. So I think the fundamental driver for everything is going to be the availability of relatively inexpensive capability to the surface of the moon. I would say I do think there's more likely probability than not that full reusability of a Starship will be achieved within 5 years. And I believe that the engine production rate of the Raptors, as well as the Starship factory, means that it's going to be very clear by 5 years that it is a fleet. This is not small scale. I believe that's the fundamental driving factor for space policy and everybody's plans for off-Earth development. And so I think we're going to have a transition from the Artemis Accords, which is just very successful, 55 countries, but it's an agreement on principles. It's not really a plan. And I think Artemis Accords, there's going to be a successor to the Artemis Accords as NASA and other space agencies recognize the capability that is becoming available. I think that people are not going to stand aside and not take advantage of the capability. They will. And I think that there's going to be an agreement about how do we explore the moon, an international lunar exploration phase on a very large scale. And also, I think there will be discussion about an international lunar base that will be large, because you can deliver inflatable habitats on a Starship for 100-ton payload. You can get an inflatable with about a 1.5 acre footprint. And that'll be like just in a single landing. And so I call those specialty HABs. And then as you have the fleet delivering these things and you attach these things, you have a extremely large, rapidly growing international lunar base. Maybe not in 5 years, but between 5 and 10 years from now is where I'm expecting things to go. And simultaneously on Mars as well.
Well, one of the things that's interesting, in 2012, when Newt Gingrich actually ran for president, he said that if 12,500 people essentially colonized the moon, that they could petition to become a new state, which might be a way for the world to kind of move forward, because you could have 55 countries from the Artemis Accords building a new model of cosmic governance that would allow for decentralized self-sustainability. And that model could then be applied to Earth, in theory, from that prototype. So we could, as 55 countries, work together to create a new model for space that promotes the idea of cosmic freedom and potentially a cosmic republic. Instead of allowing globalists to move us toward galactic empire, we could create the people's cosmic narrative.
Andrew, I hear what you're saying. I as I look at the world, I think people identify with their own people. I think nationalism is not going away. I don't think we really see evidence of that. And so I think that we will have an international base, but there will be Japanese speakers there. There will be Muslims. There will be libertarians and Mormons and all sorts of groups of people. And I think they're going to want to govern themselves in their own way, not in a totally unified collective way. And so I think there will be
have a decentralized system that allows for different governance models, but has a human rights protection, collective defense, collective economic agreements. So you could have something like NATO and the Artemis Accords kind of form the foundation of that, because you have cosmic defense and then you have cosmic development, and maybe you could work with those.
Yeah, so I think there could be a federal system, but I think there is going to be a need for people groups to govern themselves, and I think as groups establish themselves separately, they will simply declare their independence and not be bound by the Artemis Accord, and so I think they'll be able to start demarcating their borders, and I think there's going to be a number of, I don't know, states. Let's call it states, and maybe a federal system where they do work together.
It will take probably substantial amount of time for them to be able to be sustainable on their own, to be able to do that, because for the first little while they're going to be reliant on Earth. So declaring independence and then being like, well, we want water, it's not really going to work out too well. So there's going to have to be a transition period to enable self-sufficiency. But if we build in the idea of these colonies eventually are going to become self-sufficient, they're going to become responsible for themselves, they're going to gradually take that governing capacity to themselves, we could do that on Earth too.
So I do have
what you're missing here is governments are not going to establish colonies, because they establish colonies in order to benefit themselves. Companies will establish colonies because that will be their prime. They will be doing that to establish a financial base to feed back to the company. And the people living on the moon, they may expand out to develop a self-sufficient community, but like with the federal government, most likely they'll send out astronauts on a quarterly basis and keep rotating them and bring them back, and they will have very limited objectives in terms of science, because they're going to be limited in the terms of number of people that they're going to be sending. So the real expansion will come with companies deciding, this is the way I'm going to make money. And
so my view is,
I hope that I will see it in my lifetime, but my mother died at 82, my father at 84, and I'm 71.
Several raise hands. I don't know. Oystein first.
Yes, so I'll just talk about. I mean, obviously, I want everyone to be able to go to the moon and infrastructure and all that. But for the company, Solstice Mining, I think the big where I see us in 1 year is hopefully with more partners, because the big thing about beneficiation is that you need an end user, or it'll be a road with no cars, basically, right? So we need end users, we need end use cases. We want to work with more people, because being a startup trying to live off of selling stuff on the moon right now isn't the easiest. So, for sure, simulants might pull it in one direction. Our development and grants with ESA and the Norwegian Space Center and so on will pull it also in the right direction. But for sure, we want to do collaborations with people. So hopefully, if any one of you would be interested in that kind of stuff, then please get in touch with me. So the email will be in the abstract, I think, in the book thingy. So yeah. And I also want to say thank you for a really, really nice conference. I didn't catch all of it, but super nice to be part of this community. So thank you.
I think Frank has the last hand.
Yes, this might be just a hunch, but I think on the mid to long term, religious groups have a potential to play a profoundly important factor on the space settlement and because when you look at like naturally expanding populations, obviously there's in the first couple of chapters we'll be importing populations from Earth, but I suspect the casualty rate will be somewhat elevated, and cultures that can foster like a high fertility rate will probably be much more successful in these environments. And like Church has always had a lot of capital, and I don't want to go there like necessarily, but like historically, like colonization was sometimes like a religiously motivated effort. And we unless we know for sure that there's no one on the moon, and if they're all Catholic or something, we might as well go there and make sure.
Frank, let me just take a moment to reply to you. Honestly, I think if you look at the Gulf states, they've got both money and I think they've got religious motivation, not to convert anybody on the moon, because there is nobody else on the moon, but to make sure that they are represented, that their faith is represented in this new branch of humanity. So I think if you got money and you got motivation, I think where there's a will, there's a way. And if you've got money, you can do it. So I do agree that religion is going, honestly, I wonder about the Mormons too. I think that they will probably want to be represented, and they may want to be able to work towards an independent, a politically independent entity, because they tried that in the American West, and it didn't work out, but they have another chance, so.
Just wanted to mention that that was part of the talk that was going to be done by Margaret Rappaport. She didn't make it here, but she has booked about eco-theology on the moon and beyond. Interesting things, and how things will be from the social perspective be managed in the future relations out of the Earth.
That's too bad. I'm really looking forward to that.
Yeah.
Because it doesn't necessarily have to be like as much as a religion as like a faith-based system. And I mean, like a lot of things that I encompass personally in faith are like anything that I can't like personally like observe like without the use of an instrument. So like you could expand that definition into a very wide scaffold that could include all sorts of libertarians and people who have like strong political convictions, and people who have certain codes regarding like empathy. And I think like societies who are more prone to helping like the individual members will probably have a lot more success in these environments too.
I've written a book called The Book of Archism, and essentially it looks at a spiritual context of how an arc-centric society could be kind of framed in different cultural perspectives. It's only $1 on ebook on Amazon, but it's called The Book of Archism, and specifically talks about what Frank was just going on.
Very good.
I would say, I forget whether it was Frank or somebody else mentioned about the fertility rates of religious groups that tend to be higher than secular groups. I think that natural growth, through fertility, it's going to be quite a few decades before that exceeds the immigration rate. I mean, when you got 8 billion people on Earth, and you got reducing price, as the flight rate goes up, reducing price, I think the newcomers are going to absolutely swamp any indigenous natural growth. That is also assuming that we can safely have children in 1/6 gravity, which is a big question mark.
Well, you're going to have to import a lot of doctors and nurses before that point too, right?
Yeah.
We'll build special carousels that replicate Earth gravity.
Very good. Very good.
Intermittent full artificial gravity. I think that's the most plausible near-term solution to the hypogravity problem, which I think is a real problem both on the moon and Mars, based on some studies on rats.
Yeah. Very good. Nicholas?
Yeah.
I want to go ahead, please.
No, I think no, I didn't have any comments there at the moment. No.
Yeah.
So I think that might mean that we are done with this discussion. New effort and see if somebody else pops up with another question, which is fine, of course. I mean, we're here to meet and talk. So as long as somebody wants to share something with somebody else, that's fine.
I mean, I'll probably have another topic in like 5 minutes. But, you know,
shouldn't have said that, should I?
You guys have a channel on Slack, right? So we can always just like catch up there, I suppose. We happen to have like a Discord too, if you guys would be interested to brainstorm on like bio-based concepts, the archaeology solutions, I mean.
If we're still open to discussing, let me just share what I think is the natural outcome of a fleet of starships and Blue Origin, Blue Moon landers, and the reducing cost as the, with partial or full reusability plus increased flight rate of the fleet. When you have that capability, the motivation of governments to national pride has been a solid, sufficient motivation for decades to put money into human spaceflight. That's the motivation that's worked, and it's brought in sufficient money for the space shuttle, ISS, for Mir, everything. So I don't think that motivation is going away. So if you have reduced costs, that means more and more nations will be able to afford, at a minimum, one seat out of maybe 100 on a starship going to the moon for a mission of lunar exploration on behalf of their citizens in their own language. So if there's a price point there, so if the price point comes down low enough, countries will take advantage of that price point, and they will most definitely, a Thai will definitely want to see somebody from their country speaking Thai, exploring the moon and being connected to their news and to their schools as well. So I do see a real potential for a very large international lunar exploration phase. I do think that there needs to be a follow-on to the Artemis Accords to coordinate that international lunar exploration phase, because the problem is the rich countries will be able to buy multiple starships worth of seats before like a Tuvalu population of 12,000 in the South Pacific can afford even one seat. Okay. And so it doesn't seem entirely fair for, United States and other wealthy countries to visit all of the most amazing places on the moon, and smaller and hence poorer countries don't have anything exciting left to do to inspire their citizens. So I would like to see a coordination between countries to be able to allow the smaller countries to be able to still have some exciting missions that they could be a part of. And I've developed a section of our website that describes the exploration phase and how it identifies a large list of the most exciting places to visit on the moon, and then sort of shows how, from a financial standpoint, it could be divvied up to where all countries could have a remarkable experience that their nationals would appreciate and would be willing to spend 0.1% of their GDP, like the United States does, to purchase a minimum of one seat. So that's the website that describes that is developspace.info, developspace.info/international, all lowercase, if any of you guys would like to check it out. And when international people are going to the moon, some of them are going to want to leave behind representatives in a growing international base. So I see a strong relationship between exploration and the international base. And then companies, I believe countries will pay their companies to provide goods and services on the moon in support of the base, which is motivated not by profit, but by national pride and prestige. But then those companies will compete with each other for price and quality. And then as the price goes down, as the flight rate goes up,
then private individuals will be able to go to the base, and you'll have a Japanese section and a Brazilian section, etc., speaking their languages, and they will be able to afford it because the companies will then, the R&D will be done, and so they're just cranking the next incremental unit of habitat or food or life support or sanitation. And so I think the International Lunar Base will naturally grow into private settlement. That's my understanding of how it will probably go.
It'll be interesting to see also like the naturally emergent culture on the moon, because as much as everybody brings a little bit of home when they get to emigrate, there's still a tremendous amount of culture building that can be done there, especially when it comes to festivities. Especially with there was a previous talk during the conference about how in the analogs people tend to like celebrate every opportunity they can. I'm really looking forward to see how all of this is going to like interface, especially in close quarters.
There's also the issue of time zones on the moon, and that is, do you want to be awake while your friends and family in your country are also awake? And then if that's the case, how do you relate to an international base that has different people that are awake at different times of the day? I have some ideas.
Huh. I haven't thought about that. Like there's one research that comes to mind is that guy who went down in a cave to figure out like what are the natural circadian rhythm of human beings if they're not exposed to sunlight. And given that the moon has like 2 weeks darkness, 2 weeks light, I think we might see some physiological adaptation regardless of like wanting to keep up with the neighbors.
My view is we cannot adapt to the lunar circadian cycle. It's just too extreme. But and I think
weeks is a bit much. I think you can do 48 hours awake and asleep if you're your darkness.
Yeah, I think it's going to be artificial lighting is going to govern, and we'll have sunlight-like light, artificial light. And so we're going to be on a 24-hour circadian rhythm in the base, regardless of whether it's day or night outside.
And a kind of monthly season instead. So a bit less energy on the night and a bit more energy in the day.
It's like a tide.
Yeah.
But mind you, we're going to start at the poles, I believe, and we're going to have excessive energy in the locations where we'll start at the peaks of eternal light. But I think that we're going to have to survive the 3-day night and go down to low power functions during that time.
Yeah.
I do think there's going to be a strong bias when it comes to private settlers, a strong bias towards older people, because older people are the ones who have lived long enough to save up enough money to be able to buy these expensive initial tickets. And unfortunately, older people have a hard time acquiring whatever the common language is, maybe English. And so I think that there's going to be sections that's going to be a little Tokyo or a little, Sao Paulo or whatnot, where you walk through that section and these people are speaking a language, that's not the common language. And I think there's going to be some exciting, we'll have AI translation, I think, by that time pretty easily. Everybody, can speak with everybody else, but people want to hang out with their own types. And yet there's going to be group activities, including like everybody in the base getting together at central noontime for large get-together meetings, maybe entertainment or some sort of governance type of meetings and stuff like that.
Frida has her hand up.
Okay. I think one of the things that hasn't been discussed is that I think that there are going to be certain technologies that will be developed in a lunar system that are going to prove useful on Earth that we don't develop on Earth because they're not cost effective. at the present time. And the example that I gave was sewage, for example. It's always cheaper to release our waste products into a nearby water body. And now we have to recover a certain amount of phosphorus, a certain amount of nitrogen. We have to oxygenate things. But by and large, most of our garbage ends up in a garbage dump. Most of our sewage ends up in an aquatic environment. That's not going to be feasible on the moon. It's going to be a lot more feasible to develop recycling systems and go from waste to new resources, to fertilizers. And then after the technology is developed for a lunar system, somebody's going to say, hey, you know, that might be cheaper to use on Earth. And I think that that's going to be one of the contributions of the lunar system, is that it's going to improve things on Earth, having developed things that we wouldn't bother developing on Earth because they're not cost effective. That's my hope.
Agreed. Seems reasonable.
Yeah, I agree too.
I suspect we'll be exporting a lot of innovation.
Yes. I think there's a lot of innovation. There's a lot of capabilities that aren't cost effective under the present circumstances that will be cost effective under a lunar system. I mean, you consider the expense of sending food perpetually for a colony as compared to a recycling system with a local agriculture. I mean, some of the references, Japan, for example, was considering rabbits and goats and chickens.
I mean, there must be all sorts of like parallels with the earlier days of commerce, where like there was a lot more geographical friction, so to speak. So like all sorts of products came at an incredible premium, including like spices, which is not a really big deal nowadays. So I'll be really interested to see what type of economic pressure happens on any lunar economy. I think exportation will probably favor a lot of like luxury goods in the early days. Probably bio-derived. That would make a lot of sense from like a prestige standpoint, like Doug mentioned. Oh, this wine was grown on the moon.
Yeah.
Oh, that's one thing I wanted to touch on. I know that like humans probably won't be able to adapt like from a circadian perspective, but if plants were to do it somehow, like it could probably affect like the quality of the experience that people are having from either the food or the drinks. I don't know. Just food for thought.
Well, it may be on Mars that we find organic material that we could use as food, but I don't think anybody has proposed that for the moon.
Oh no, I meant like maybe growing grapes locally and exporting the wines from a.
Well, but I think that the grapes would have come from Earth to begin with, and I think that the novelty of being able to show that you're wealthy enough to be able to afford moon-grown wine because it's rare and you want to show off that you have economic power. I don't know if that's the basis for a complete economy or not.
Maybe
But I think
Dubai.
definitely if people want to have wine on the moon, I think alcoholic beverages have been made from almost any organic material.
Maybe we could specialize something that's like lunar adapted. Give it a local cachet.
It will work for a while, but it won't work long. I agree with that.
Yeah.
Yeah.
Novelty factor.
Just gonna send a distillery out there. Rum on the moon.
Oh, Doug has his hand up.
Yeah, I'd like to introduce one additional idea that in my space development network we do focus quite a bit on this, and that is really the initial permanent crew. And the idea here is at some point humanity is going to start expanding beyond Earth, and whoever those first people are who sell their homes on Earth and they settle down off Earth, those may be in fact very historic people. We may know who they are, and in the United States, we've got this story that we tell ourselves. We celebrate every Thanksgiving, and that is the Thanksgiving story. Plymouth Rock, and ask any American, they'll be able to give you some sort of rough story about that we consider to somehow be sort of connected to the starting of our country. And one could imagine parents in the future saying, hey kids, let me tell you the story of when humanity began to move beyond Earth. And they tell about certain people that settled down. So this is a very interesting historic opportunity. It's almost a historic prize to be seized by whoever sends the first people to settle down, literally settle down off Earth. And I think that instead of just not planning on writing that story, and you get this muddled, well, we had some astronauts who, when they picked up more rocks and then they returned, and then there's base, and then people started rotating through the base but heading back, and then somebody, we're not really sure who, but somebody actually settled down, and who were those people? Instead of having a vague story like that, perhaps we should actually choose to write the story of when humanity began to move off Earth. And so my network, this is one of the things that we advocate is, let's actually write this story. So the idea is to actually have a group of private individuals, about 8 individuals who are diverse, they're equal numbers of male and female, and they go to the moon and settle, they sell their home on Earth. They've got to be socially free. They can't leave a dependent child back at home or a spouse back at home. Otherwise, they're not going to stay on the moon. So like young couples who get married and then they can move away from their hometown, it'd be sort of like that. People are socially free to leave Earth. And to have these 8 people be the first 8 people who literally settle down and hence start settlement. And by that, but the definition of that in my mind means that if you're settling down, you're basically establishing a home. That's what settlement really is. So we view it as a private activity, not government astronauts who are settling down. It's not really the role of government to settle so much as it is a private activity. But these people could be workers. They could be workers for a company. That could be demonstrating protocols. They could be like demonstrating growth of food. They could also be receiving payload deliveries, like Starship deliveries, and sort of helping get things set up for the next phase, like the international phase. And then we would be watching these 8 people, and these people are not doing geologic exploration on the moon. That's not really their purpose. Their purpose is to settle down, and settle down means living. And so think about what these 8 people would be doing in terms of growing their own food. There'd be a cooking. They'd receive their produce and make recipes, and we would all be following this with like a once a week TV show. I think one of the more remarkable things would be the arts. As people settle down, they start living life. Arts can become a part of that. And I got to tell you, dance in 1/6 gravity is going to be an absolute phenomenon. And I think that people of the world are going to think this is just incredible. And so the selection of these 8 people, I would open up to the world. And in language, if one person knows all of the Latin languages, all 5 of them, one of them knows as many of the Slavic languages as possible, Arabic, Turkic, and these 8 people can speak to about 75% of the world in the language that they know, maybe 80%. But think about, selecting them for music. If you're fairly decent at the violin or trumpet or whatever, then you're more likely to be selected to be part of these initial 8 people. And of course, as was mentioned, celebrating holidays. If there's an Indian as one of the people in this group of 8, well, there's an Indian religion that's called Holi, which is very popular amongst Indians and Hindus. And so I could imagine, us watching the story being played out, real life story. I mean, this is truly reality TV, being played out, and this is the story that goes down in history as to when humanity, established a permanent foothold off Earth.
You touched on a really important. I mean, it's a really interesting train of thought. I really like the last bit where you touched on the reality TV aspect of it, because as you were describing the whole thing, I was kind of wondering, like, how would these settlers and what relationship they would have with other people who are on other terms in terms of why they're on the moon, what their work days look like, if people are going to get a little bit jealous, if maybe, the personality hires, they spend more time working on arts and things that are, impressive for the people at home. I suppose you could rationalize this if there's like a significant amount of sponsor funds that are associated with such activities. We need all sorts of jobs for all sorts of purposes. I, for one, would really like to see a Lunar Olympic. I think it would be a really interesting making effort.
Yeah.
But I don't want to
dances. I really like the discussion on dances. I've thought about that.
Martial arts on the moon, that would be incredible.
You
just throw the guy.
And sports, but dancing as such. I mean, if you dance fast enough to leave the floor, then it takes quite a long time. So if you're dancing a dance that is reasonably fast, you will need to actually use the ceiling. So you need to flip up and down rather than just jumping from the floor.
Yeah. So let me share with you. I've actually met on a few occasions with the University of Arizona at Tucson School of Dance, and I actually met with them. I'm a physician, and it's a weird conversation because I show into the School of Dance and I say, "Hi, I'm a physician and I'm a space advocate, and I'd like to speak with one of your faculty about dancing on the moon. Is there anybody I could speak to?" And they're like, "What? Is this for real?" And then as I sit down and start talking with them, they're like, "This guy's serious," and then they got excited, Yeah. And we got close to having a student do this as her, her thesis. And probably how it would work out is you'd have to have a contraption to offload, but like 5/6 of the weight. So it's a harness and dark, dull, non-reflective tethers, sort of piano wire sort of stuff. And then to develop a dance routine like Nicholas, yes, when you are in 1/6 gravity, this means you can jump 6 times higher, and you also spend, I believe, 6 times more time in the air. And this fundamentally changes the nature of dance, because if you've got good traction with your shoes, which is an issue, but if you get good traction, you can go running across the floor, and as you can actually start running up on the walls while still powering yourself running up the walls. So there's some interesting physics. And I believe that you could actually get up to the ceiling, whether, of course, it depends on the size of the room, but could you get across the ceiling before you detach and start falling down?
If it is circular loop, you can, but you can actually do that on Earth. There is a YouTube video with a guy running the loop.
Wow.
On Earth.
Okay. So it's definitely
that is possible even on Earth. I've been talking about that for a while, as you could do it on the moon, and then I found a YouTube video with a guy doing it on Earth. I was a bit disappointed.
Wow. So there is a lady, a faculty member there at Tucson, and she brought up something that I would not have thought about, and that she's talked about the choreography of Dance on the Moon. Think about it. On Earth, because we have full G, then every step is typically a beat. But on the moon, when you jump up, it's going to take you 6 times longer, so you're going to be airborne for 6 times longer. So in fact, you may be not standing, hitting the ground, except for each measure, and then the beats are when you're in the air. Just like high diving is a long time, you can do multiple moves during a high dive. I'm sorry, high dive board, into the swimming pool. And so you could actually be doing movements of beats while still in the air, and then only at the measure do you hit the ground. And so it would be quite a different choreography. Plus also, like, if you have two people dancing, you could do all sorts of sort of gymnastics, almost like cheerleader type movements, because lifting the other person, they're going to have the same momentum, but their weight is going to be 1/6. So it's going to be amazing.
Yeah. And you could also do dances where you actually use the ceiling by jumping, because it's easy to jump. I mean, you can do a somersault on Earth as well, but if you do it on the moon, you can actually keep the speed up to normal dance speed by bouncing from the ceiling.
But the people who are selected, like out of the 8, 2 people who are fairly acrobatic and dancers, and you select them because they have that talent. Then what you do is somebody develops a dance routine, and then, in my opinion, in private on Earth, using these tethers, they practice and they get it down, they get the routine down pat. And then when they arrive in the moon as part of the initial permanent crew, they also in private practice in the lunar environment until they master their routine that they mastered on Earth, but they master in the lunar environment. And now they're ready to perform.
Yeah.
And this is going to hit the watching public mind. It's going to explode their minds, because they have never seen anything like that, and they honestly have never even thought about anything like that. And yet they're witnessing it for reality on the moon.
Yeah.
And for the music, it could be novel music that has this first performance. What's the first performance of music called?
Opera prima, or no?
There's a term for it, but
Yeah.
the first time it's performed could actually be from the moon itself,
The premiere.
where it's never performed in public.
Debut.
Yeah.
Yeah. I really like your idea, the making it a story. I think that will help a lot in getting it across. We remember stories. We don't remember facts and places. We remember stories about them, rather.
I suspect that the first couple of settlers will be celebrities one way or the other, much like the astronauts were. Even if they're even if they're just space plumbers, they're entitled to some degree of renown. Probably even more so, because future space culture will probably have people like hugely favoring like hyper competency for like survival's sake. So like we don't necessarily like know what type of like value filter that these people will be looking back upon the first pioneer. Personally, I don't want to get too macabre about this, but I think it's really important point to touch on. We haven't had any dead people on the moon yet, and this is going to alter every social dynamic significantly. I think one of the major reasons why people might want to establish themselves on the moon is because, just to paraphrase Tucker Carlson, my whole family's graves are here, and I'm not going anywhere. Like, if all the people are already settled on the moon, like permanently, as small piles of dust or whatever gets out of the reclamation cycle, like you're gonna have people wanting to stay there because they're close to family.
I think, though, there's going to be a difference, because the European people who came to North America as colonists pretty much were leaving a bad situation. They either belonged to a religion that was not accepted, the Pilgrims, for example. I don't know whether the people who came had the wealth to pay for the ship that brought them. Most of the European immigration was people who either were despised in their locale, and very often it meant saying goodbye to their parents and family that they would never see again. But I think that the first people who move to the moon are not going to have the money to pay necessarily for their passage. They're going to be heroes and heroines. They're going to stay in touch with their family by the capabilities that we're using right now. So I think that that's going to be somewhat different. I think that they will be celebrated as people who are very brave and willing to make the transfer. I also rather wonder whether children at some age, maybe the age of 7, will be sent to the Earth to learn skills, because otherwise there's a number of years where children are not productive in the sense of contributing. So I don't know whether children will be sent to Earth for some period of time, maybe to strengthen their bones as they're growing. But I think that people are not going to be that isolated because we have communication capability that we didn't have at the time, for example, when North America was colonized.
So Frida, let me just mention, because 2.6 seconds round trip speed of light, time delay between the Earth and the Moon is not too much. We can be telepresent. You can be on Earth looking into a camera, and the image of your face can be on a screen that's on a Segway sort of robot that you can move around, and so you can meet with people and talk with people even though you're on the Moon. You can go to family weddings, you can go to family graduations, family Christmas get-togethers, and you can be telepresent there and carry on with some delay, but carry on a reasonable conversation with your loved ones and your friends. Okay.
Yes.
I mentioned this.
Agree.
Yes, I mentioned this because, in my opinion, getting into the whole Moon versus Mars debate, in my opinion, the Moon has some pretty strong advantages, even though there's fewer resources, and probably more importantly, the resources are not as accessible on the Moon as they are on Mars. That nonetheless, I think the Moon has some rather strong advantages over Mars. Number one, probably the biggest one, is round trips to the Moon are 70 times shorter than the Earth-Mars window opening up every 26 months. Okay, a 70-fold factor is absolutely huge when it comes to the number of trips that you can make to the Moon versus make to Mars with a given number of rockets, vehicles. Okay, and also, if you look at the group that we're in right now, or practically any space conference that I've ever been to, men outnumber women about 85% to 15%. And even though, like myself, probably some of us here are married, but the women are not as interested in the men in these future, sort of not so practical sort of things. And I think to try to convince a wife to significantly break social ties with loved ones and to go to Mars and be in connection only by video emails versus being telepresent if you're on the Moon, I think this may be a pretty significant selection factor for people who are saying, well, we've got enough money to go to Mars, but my wife is unwilling to disconnect the ties, and so therefore let's just go to the Moon. Okay.
Yeah, but I think that some of these things will change.
I have the opposite.
For example, one of the problems we have at the universities right now is that 60% of our students are women. And, if you look at any of the feminist magazines, Ms., for example, women very eagerly are moving into a lot of areas. When I got my PhD in 1959, it was very uncommon for women to do so. But now we're almost talking about giving special scholarships to men because they're becoming rare.
But in our meeting right now,
I do. I have the opposite experience actually with the interest. When 20 years ago, when I was last trying to run a Moonbase analog, I was speaking at different meetings for quite a lot, and I always asked anybody at the end of the presentation, is there anybody here who would want to live on the Moon? And there was always at least somebody. But my experience there was that it was much more common to want to live on the Moon with young women than with old men, and it was both the directions. The lowest response I got, and it was a very hesitant guy who after a while raised his hand. That was the Swedish National Aeronautical Club. So you kind of thought that they would be interesting in space and living in space. And the most replies I got, it was girls who were, I think they had actually chosen to go to the university because they were interested in technology, so quite biased. But there were over half of those were raising their hands on that. They wanted to live on the moon. And when they left, I heard one of them ask the other, but why don't you want to live on the moon? She just couldn't understand that was not what everybody wanted.
Well, I do think young people are more risk tolerant than older people.
Yeah.
But older people have much greater savings, and so in terms of, it's Elon in his Guadalajara presentation talked about the Venn diagram, the intersection of the people who want to go and the people who can afford to go. And what we may have is that young people may be more willing to go, but they cannot afford to go. Older people may afford to go, but they are maybe less willing to go.
So
and I'm not quite sure exactly where that will play out.
So
okay, you've left off parents that might be willing to pay for their kids to go away.
Yeah, maybe the parents will pay for the ticket and pack your bags.
maybe wives will be glad to let their husbands go.
But yeah, one thing that that came to my mind too is that like maybe one of the best way to ensure like retention of the crowds on the moon, especially if like you get to see the Earth like every time you look out the window, is that you could import people by groups, kind of like what Doug has mentioned, but on a scale that like you'd have like an entire community that is interconnected and would not necessarily like potentially have too much contact with the outside. Like that could be somewhat like engineered, like you pick certain locations and then you offer them all a ticket or something.
Well, so we have some historic precedents for that. The ship that took the pilgrims to they're headed to Jamestown, but they're blown off course, and so they ended up in New England, and this is where Plymouth Rock came from. They organized themselves in New Plymouth, which is in southern England, where they left. I think these people were mostly from, I'm sorry, the Danish are from which country? They're Denmark? No, I think they were from the Netherlands. Most of them were actually from the Netherlands, if I'm not mistaken. But they went to England and they organized themselves, and so not all of them, but most of them in that ship were actually from the same faith community and maybe from the same country. And so I think it's quite interesting when you have a ship with about the same number of people, 100. I think Starship could probably go in 3 days to the moon. I think you can bear with more cramped quarters than going to Mars. So you might have 150 or maybe even 200 people going to the moon. And I could imagine you might want to go with a group of people who you are moving together. I truly could see that.
I don't want to like put too much emphasis on that aspect, but like I think space being a tyranny-prone environment and cults being the way they are, I think that the moon might be a little vulnerable to culty behaviors. Maybe, I don't know. I just get a hunch. There was a huge moon cult in South Korea, right? Like a fertility cult. I think there was a governmental scandal in 2017 or something. I'm sorry, I'd have to dig that up, but
So the thing you mentioned about the risk of tyranny are on the moon. Are you talking about whoever owns the air controls the people? Is that what you're talking about?
I mean, not necessarily the moon, but I mean, the moon has the advantage of like being in close communication with Earth. Like this scenario is much more prone to happen in like faraway places, like asteroid belts and places like that, I suspect.
So I do think that tyrannical governments off Earth are going to be difficult, because if you have a choice, if you're a private individual and you've got money and you get to choose which settlement do I go to, are you going to choose the free settlement, or are you going to choose the settlement that's your life is controlled by somebody who owns the production of oxygen? To me, if you have a choice of going to the international settlement or the CCP settlement, I think most people would probably not want to spend their own personal money to go to the tyrannical settlement. I think tyrannies are going to have a hard time attracting people off Earth.
Absolutely, unless they're forced there, like Nicholas is mentioning. Maybe they'll get the Australia treatment.
Well, then they've got to get permission to launch on a starship, and maybe they will not get that permission if it looks like a bad situation.
Isn't China building a starship alternative?
Yes, they'll be several years behind, but yes.
I have no idea what it's going to look like, but given that human labor is very helpful for all sorts of applications, like I could. Nah, that's a topic for another discussion. Like the interface with like military tech and like space tech, especially with like the context of China using them, is somewhat like scary, to be honest. But I'll do it in private message.
Yeah, I think China's too far. I think SpaceX and Blue Origin are going to be in the lead, and then the number of countries that would, look at our Artemis Accord versus their International Lunar Research Base. They've 83% of their signers are dictator countries, and for the Artemis Accord, it's something like 13% or something like that. So I think other countries don't want to fit into some totalitarian's paradigm.
That quote about space being a tyranny-prone environment is from Charles Cockle. So he wrote a paper about that. I think it's worth a read. I mean, he was focusing on the fact that you can get control of resources fairly easily. And so he was promoting freedom, I think he called it freedom engineering, which is making sure that you design things that are distributed instead of centralized, so that nobody can take control. And because if somebody takes control of your air, you're kind of going to have to do what they want you to do. So
it's just not going to be. It's just not going to be popular.
Well, it won't be popular, but it can happen, right? So the issue is, it's like, I'm not going to go there, but what about the people who are already there?
Hopefully, they will be able to get in a vehicle and drive to the other settlement.
Possibly, yes. But that's part of the design, is to design such that it is distributed like that, so that you are able to get in a vehicle and go. There are other settlements close by. But it's an important design factor.
Would the people there be able to get on video back to Earth and say how terrible their life is? And would that discourage other people from being pushed into the rocket that takes them there? To me, this is a improbable scenario.
Well, I think if you look around the planet Earth, you will find it all over, even without
problems. That's space, because right? people were born in North Korea and they didn't have a choice. When it comes to off Earth, immigration is going to be the large portion of the population for the first 6 decades, 7 decades, something like that. So it's going to be a choice as to whether people go there or not, as opposed to you're simply born in the country, you didn't really choose to do that.
Well, that's going to happen on the moon. I mean, initially, sure, but so. So should we wrap this up, Nicholas?
Yeah, I think it starts getting time to wrap it up. Let's.
The audience is dwindling. Yeah.
Yes.
Yeah.
I wanted to thank you, Nicholas. It's like this has been great. I really appreciate you doing all the work.
Yeah, thank you too. You have contributed almost everywhere. And everybody
Very
else.
good.
Thank you.
It was a terrific conference. Thank you so much for putting it together.
Yeah, it's been great, Nicholas.
Thank you for running this.
Yes, appreciate it.
In 1
Thank
year
you so
time,
much.
I see myself exactly here.
Yeah,
Yeah.
very good.
Me
1
too.
year's time. See you in a year.
Oh crap! I
Very
think I
good.
hear something outside the hab. I'm gonna have to go check it out.
Yeah.
Oh, very good.
Bye, guys.
All right. Okay. Well, Nicholas, it's been great to be in this workshop, and thank you for everything and for the opportunity to participate.
Yep. Thank you, Tito. And
Thank you.
I'll send you the recording.
Oh,
As soon as
great.
I've got it.
I'll send you the slide as soon as we.
Yeah. Thank you.
Okay.
Cheers. Bye.
Bye.
Presentation.
Bye.
Thank you. Have a nice day.
Bye bye, guys.
Jesus name.